Hello guys, till now we have seen all the metrics that we use in classification and regression. Now I will tell you the underlying concept of having a validation, that is the generalization of models. But in generalization we face certain problems in the form of underfitting and overfitting. Underfitting means that the model is trained very badly on trained dataset, meaning the accuracy of the trained model on a trained dataset is low. Whereas overfitting means the model is trained well on the trained data, but it's showing less accuracy on the testing data, meaning the generalization is less. We can understand the underfitting and overfitting by a simple example of joining dots. Overfitting will be able to join all the dots coming in its way, whereas underfitting might not even connect minimum two dots. So, it's basically the coverage of data points. In continuation with the overfit and the underfit, I would like to tell you something about the bias variance trade-off. The goal of any supervised machine learning algorithm is to best estimate the mapping function for the output variable y, given the input data x. The mapping function is often called the target function. The prediction error for any machine learning algorithm can be broken down into three parts: bias error, variance error, and irreducible error. The irreducible error cannot be reduced regardless of what algorithm is used. However, bias error and variance error can be reduced. But before that, what are these? Bias are the simplifying assumptions made by a model to make the target function easier to learn. Generally, parametric algorithms have a high bias, making them fast to learn and easier to understand. Bias generally refers to the favorness of a particular value, whereas variance is a kind of the variety of data or the differences in the data. For a model to be good, the bias and the variance should be equally low. In overfit, the variance is always high, whereas bias is low, while on the other hand, in underfit, the bias is high and the variance is low. So, for the optimal solution, it is a necessity to have both bias and variance to be low. Thus, we need to tune our model in a way that both bias and variance of our model should be minimum.